So this lesson is about angles. We're introducing angles, and angles is something that I'm sure you heard of before, but we're going to talk about explicitly using language what an angle is and means. So first let's just talk about the definition. So you can pull out your definition sheet, and if you need a second to do that, you can pause the video, but I'm going to go ahead and define this here as an angle is basically two rays that share an origin. Okay, so anytime we have two rays that share an origin, that's when we have an angle. So here, if you look here, we have two different rays. Here's one ray, here is another ray, and if we move them so that they share the origin, then what you will see is that forms an angle. And so this is the angle right here. And there are a few things that we need to delineate. So I'm going to draw these rays, when they share an origin, become the sides of the angle. So there's a side and there's a side. The angle has two sides. And then we refer to this initial point right here, we refer to that point as a vertex. Okay, so an angle always has at least two sides, and then it has the common point that they share we call the vertex. So that's an angle. It's two rays, one ray, two rays, and then when they share the same endpoint, they become sides, and we call them a vertex. So if I were to name this angle, let's say I called this point A, and then let's say I added a point over here that I called B, and I added a point right here called C, then the sides would be rays AB and rays AC. Now, we're going to talk down here, if you look, this is naming angles. So if you want to write a little spot in your notes that says naming angles, I'm actually going to get rid of that. That's what we're talking about now. How do we refer to this angle? How do we name it? Well, you can do it one of a couple of ways. You can start with a point on the side and travel this way. One way you can name this angle is to name it angle BAC. So this means angle right here, and then we go just from one point on one ray to the vertex to another point on another ray. So that's angle BAC. And you might be saying to yourself, well, why couldn't I write it the other way? And you could. I could also write this angle as angle CAB. Okay. So this angle BAC is the same as, and is the same angle as, angle CAB. Those are both the same angle. Another way to refer to it might just be with the vertex. So in other words, we could also just say angle A. We could also just call this angle A. So lots of different ways to name this. We could call it angle BAC, angle CAB, and angle A. Now, you also see this note down here about congruent angles. What does that mean? Well, just like we had congruent segments, right? If two segments have the same length, then they are congruent. Here, if two angles have the same measure, then they are congruent angles. So congruent angles, you can add this to your definition sheet, and I'll write the definition down here. Two congruent angles are angles that have the same measure. That's congruent angles. Okay, so two angles that have the same measure are called congruent angles. So there's that. Now, there's another postulate that we're going to introduce right here, and it's called the protractor postulate. And here's what this means. Here we have a protractor. You've probably seen one of these before. And I'm going to leave it. How do I just move it? There we go. And basically what this says is that I can take a ray and I can move it around so that one side of the ray is on 0 and another side of the ray maps to one of these numbers. And similar to how our ruler postulate, which said that a point can represent a value, we have rays here that can represent these values from 0 to 180. Okay, from 0 to 180. So let's say, for example, that I wanted to find the measure of this angle. I could take this protractor and move it so that this one part was on the origin and this ray was on 0. So you see how I laid this ray, ray AC, right over the 0. And then I could take this little pointer, where is it? There it is. And move it to represent a number. And we're going from 0 up, not from 180 up. So we're going from 0 up. So this angle looks like it would be about, I don't know, maybe 27 degrees. And I can click this, and look, there is our angle. Then this, we could say that because this ray rests over 27, then this angle has a measure of 27 degrees. And so that is how we measure angles. We lay one side of the angle, we think of it as being equivalent to this flat 0 right here, and then we go all the way around till the other ray. So you can see angles can be measured all the way from 0, if we measure them in degrees, from 0 to 180. A straight line is 180, but we'll get more into that in a second. But that is how we measure angles, and that's using the protractor postulate. Now, let's move along. Points within angles. This is really, really difficult stuff, guys. It's really complicated. And basically, this means this. Points can have one of two relations with an angle. There can be an interior point. So I'm going to box this in red so that you can see the interior point is red. Or there can be an exterior point, a point outside of an angle. Okay, so the green is an exterior point, the red is an interior point. So, like I said, really complicated stuff. A point that's within an angle is an interior point. A point that's outside of an angle is an exterior point. Now, there is an important thing. Is there more that's going on here? Is there a distance between this point and this point? Yes. So if I wanted, I could draw another ray right there, and that would create, look, two more angles here. Same thing. I could draw another ray, and now I'm just creating angles all over the place. We have this angle here. We have, obviously, each of these are their own individual angles. And then you might also see that there's an angle right there. And if I go the other way, there's an angle right there. So just adding some rays creates, let's see, between 1, 2, 3, 4, 5, 6 different angles. So there are lots of ways to create angles. So let's continue. There are 4 specific types of angles that we talk about, and you need to get each of these down in your notes. And those are acute angles, right angles, obtuse angles, and straight angles. So what I want you to do is I want you to pause the video right now, and I just want you to draw each of these in your notes. And then when you're done drawing them, you can press play, because we're going to say something about each of these angles. Okay, so now that you have these drawn, let's talk about what each of these mean. An acute angle means this. It means that the angle is less than 90 degrees. So if we were to call this angle A, then we would say angle A is less than 90 degrees. Okay. Here, a right angle is when angle A equals 90 degrees. When angle A equals 90 degrees, that's what we call a right angle. Here, an obtuse angle is when, if we are calling this angle A, is when angle A is greater than 90 degrees. And then a straight angle is when, if we call this angle A, is when angle A equals 180 degrees. Okay, so basically this is a flat line, or you might see these are two opposite rays right here. So either when we have two opposite rays or a straight line, we call this a straight angle, and that measures to 180 degrees. Okay, let's talk about something really quickly. Let's talk about adjacent angles, okay? And you can define this. You can add this to your definition sheet. So you can go back to your definition sheet and go ahead and start writing a new entry. And then I'm going to define it here. So if you need some time to do that, pause the video. But adjacent angles are two angles that share a side. Two angles that share a side. And it's at least two. There may be more than two, but it's at least two. And they also must share a vertex, but that's kind of obvious. So we have two angles here. If I take this angle and I put it right here, then what we have are two adjacent angles. They share a side, and then they share a common endpoint right here. Okay? So we have two adjacent angles. And just like we had with the segment, there is also an angle addition postulate. Okay? So what the angle addition postulate says is that if we have two adjacent angles, then I can find the bigger angle by adding the two smaller angles together. So let's add some points here so that we can enumerate. Let's say I'm calling this point A. Let's say I call this point B. Actually, you know what? I'll call that C. I'll call this B. And I'll call this point on here D. So if I want to find the measure of angle BAC, that's the bigger angle, BAC, then I can find that by adding the two smaller angles together. Angle BAD with angle DAC. Okay, now I also could have referred to this angle up here as DAB if I wanted to, or this one down here as CAD, but I just chose these because just because. And so what the angle addition, this right here is essentially the angle addition postulate. That if I have two adjacent angles, to find the bigger angle, I can add the two smaller angles together. So we're going to do that. So angle BAD is clearly 39 degrees. And angle DAC is 35 degrees. And 39 plus 35 is 74. So what we would say is that angle BAC equals 74 degrees. Ta-da! And that's using the angle addition postulate. That's pretty simple. Okay, so now what I want you to do is I want you to draw this picture in your notes, and I'm going to show you what I'm going to ask for, and I'm going to zoom out a little bit here so you can see it. I want you to draw this picture, enumerate, draw everything just like it is here, and then I want you to try and find the measure of each of these angles. Okay, so take some time, draw this picture, get this down in your notes, and then find these angles. And when you're done, come check them with me. And then that is our lesson and our introduction on angles.